Hey, this is Mrs. Radigan with a lesson on arithmetic series. A series is the sum of the terms in a sequence. We learned a sequence before was a list of numbers. So a finite sequence and series have a given number of terms, 1 through n. And an infinite sequence or series continues without n. We're just going to find sums of finite series of arithmetic nature. So arithmetic series means that the indicated sum of the terms of the arithmetic sequence and here is the sum formula. So you take the number of terms divided by 2 and then you multiply that by the sum of the first and the last terms. Another way to write a sum is if you see this sigma and it has a starting term number. So this would mean the first term is term number 1 and then the last term is term number 5, and then this is the formula to get the term number. So if we wanted the first term, we'd plug in a 1 here. 3 times 1 plus 2 is 5. If we wanted the fifth term, we'd plug 5 in here. So 3 times 5 plus 2 is 17. Okay, so to start with example 1, it says find the sum of the finite arithmetic series and write it in summation notation. So if we want the sum, we need to know how many terms they have given us, but they don't tell us that. So we have to find that first of all. We need to know the first term, which is, the first term is given here. So this right here is A1. And then the last term right here, AN, is 29. So that's AN. So step 1 is to find N. So we know that if we take 5 and we add some common difference, n minus 1 times, we're going to get at 29. If we look up here, we can see that our common difference equals a positive 4. So we're going to plug that in right there. So we're going to do 5 plus 4 times n minus 1 equals 29. So if we solve that and we subtract 5 from both sides, we get 4 times n minus 1 equals 24. We get n minus 1 equals 6. So that means there are 7 terms. So now we're ready to come over here and plug that into the equation. So the sum of 7 terms is 7 divided by 2 times the first term, which is 5, plus the last term, which is 29. So the sum of the 7 terms is equal to 3.5 times 34. So that sum of the 7 is equal to 119. To write that in summation notation, we use our sum from n equals 1 to the 7th, and then we write our explicit formula, which we can get from up here. So we know that we had a formula of 5 plus 4 times n minus 1. Okay, next example, we are given the summation notation and asked to find the sum. So to find the sum, we need to know the first term. So we're going to plug 1 in for n. So 4 times 1 plus 5 is 9. We need to know the 21st term. So we're going to plug 21 in for n plus 5. And that's going to give us 89. And then we just use our sum of the 21. And we get the total number of terms, which was 21 divided by 2, times the sum of the first plus the last, and that sum is going to give us a total of 1029. If we want to use our calculator, we're going to go to the math function and then you can just go up to get down, go to 0 summation notation, and we're going to go to x equals 1 to 21, and then we're going to put in our function 4x plus 5, hit enter, and there is our 1029. Okay, part B, same problem, but this time we're starting with the third term. So we're going to plug in 3 as our first term, and that's going to give us negative 23. And then we're going to plug in 9, and that's going to give us negative 71. So when we're finding the sum, we have to figure out how many terms we have. We don't have 9 terms because we start with the third. So if you go from the third to the ninth, you actually have 7 terms. So your sum is going to be those 7 terms divided by 2 times the first term in the series, which was negative 23, plus the last term, which was negative 71. And that sum is going to be 3.5 times negative 94, which is negative 329. Again, if we do that on our calculator, we're going to hit our math button, go over or up till we get to summation. We're going to type in x from the third term to the ninth term, and then 1 minus 8x. Hit enter, and there is our sum. Okay, so in this one, we know that we're finding the sum of this. We know that A1 is 16. We know that we have 30 terms, but we don't know what AN is, so we need to write an equation for AN. That means we need to know the common difference. So here we're subtracting 4. So our common difference is negative 4. So if we were to write an explicit formula, we would have AN equals A1 plus our D times N minus 1. So if we want to solve for the 30th term here, we would just plug in 30 for N, and we would get 16 minus 4 times 30 minus 1. So our 30th term is going to be negative 100. And then we plug that into the formula for sum of the 30 terms. We know we have 30 terms divided by 2 times the first term plus the last term. And we get a sum of 15 times negative 84, which is negative 1,260. If we wanted to write that in summation notation, we would write the sum from n equals 1 to 30. And then our equation was 16 minus 4 times n minus 1. Okay, again, we're finding the sum. This one right here is clearly A1. We can see that our common difference equals a positive 2. And this is our AN. So we just need to know what is n here. So we're going to take negative 6 and add 2 n minus 1 times, and that should land us at 36. So 2 times n minus 1, if we add 6 to both sides, is 42. So n minus 1 is 21, and that makes n equal to 22. So now we have our number of terms. We know our first term is -6. We know our last term is 36, so we're going to take number of terms divided by 2 times the first plus the last. That gives us 11 times 30, which is 330 for a sum. And then if we were to write that in summation notation, we're going from the first term to the 22nd term, and our formula is -6 plus 2 times n minus 1. Okay, in this problem we have a 30-row theater, so that tells us that that's our total number of terms. And we know that each seat or each row increases by 1 seat, so that means our D is 1. So if we want an explicit formula, our nth row, we start with 10 seats, because up here it said A1 was 10, and we add 1 to it, n minus 1 times. So you might want to make that AN equals 10 plus n minus 1, or AN equals 9 plus n. If we want to know the total number of seats in the 30th row, we're just going to plug 30 in for n. So A30 is equal to 9 plus 30. So A30 is equal to 39 seats. And then if we want the summation notation, we know that we want the sum from the first row to the 30th row with an equation of n plus 9. And if we want to find that sum, we're going to take the total number of terms, which is 30, multiply the number of seats in the first row times plus the number of seats in the last row, and we will get the sum of the seats in the 30 rows to be 735 seats. Okay, in this one, we want to know A20. We're given A1 is -3, and the sum is 320. So our formula for sum is going to be Sn equals n over 2 times A1 plus An. So we know the sum is 320. We know there are 20 total terms. We know A1 is -3, and we're trying to find A20. So 320 is equal to 10 times -3 plus A20. So we divide both sides by 10, and we get 32 equals -3 plus A20, and that makes A20 equal to 35. This one's a little bit trickier. It gives us that we're looking for A1. It gives us that we have 10 terms because S10 means 10 terms and our D is 4, but we don't know what A1 or A10 are. So we're going to have to write an equation, an explicit equation. A10 is equal to A1 plus 4 times 10 minus 1. So A10 is equal to A1 plus 36. Remember, our sum formula is Sn equals n over 2 times A1 plus An. So our sum of 230 is equal to 10, because that's how many terms we are, divided by 2. Now we don't know the first or the last, but we know them in terms of each other. So this becomes the sum of A1 plus 36. So 230 equals 5 times 2 A1s plus 36. So 46 equals 2A plus 36. 10 equals 2A. And A1, and A1 then equals